Hello all. Today we are solving LeetCode problem number 3634, minimum removals to balance array. So we are given an integer array called nums and an integer called k, right? So an array is considered as a balanced array if the value of its maximum element is at most k times the minimum element. So this can be represented as array uh, array or yeah, this is nums, right? So nums of max element is at most, so less than or equal to k times the nums of minimum element. So this could be represented in mathematical terms as equation 1, right? So you may remove any number of elements from nums without making it empty. So you have to return the minimum number of elements to remove so that the array remains balanced. So the ask of this problem is you are given an array and you are given a value k, right? So now you have to make sure the array is balanced. So you have to return the minimum numbers that can be removed, or minimum elements that can be removed, so that the array becomes balanced. So here they have given a note: an array of size 1 is considered balanced as its maximum and minimum are equal and the condition always hold true. So they say there that always a single element array is always balanced. So with this all, how are we going to solve? So first we have, when we look into the example 1, we have 2 1 5. So the minimum value among these three is 1 and maximum is 5. So the array 2 1 5, right? So here the equation will be 5 less than or equal to 2 times k is 2 and 1, so which is not equal, and this is not satisfied. So it is because of that this array 2 1 5 is not balanced. So if we remove this 5, what happens is it becomes 2 and 1. So min remains 1 and maximum becomes 2. So now based on the equation, this will be 2 less than or equal to 2 cross 1, which is true. So now balanced. So it is due to this reason we are removing only 5. So this cost us 1 values, so which is nothing but the minimum value. So we will go ahead and return 1. So hence the output is 1. So how can we solve this actually? So the first idea which will strike in our mind is thinking about sorting, because we need to find if the array is balanced, right? So using that we have to use sort to find the minimum and maximum. Well, the ask of this problem is completely different, which is nothing but minimum number of elements to be removed in such a way that the array remains balanced, right? It is not about checking the array if it is balanced, it is all about the minimum operations. So how do we find? So the intuition which I am thinking and which I am using here is we have to find the maximum subarray, or we have to find the subarray with which is subarray is balanced, right? We have to find a better, I can put it like we have to find the balanced subarray with maximum size. So this will be easier because with the help of pointers, two pointers, you can find you can check the subarrays, right, with maximum size. We can You can find if the subarray is balanced, and if you can find the maximum size of the subarray, and then what you have to do is subtract n minus the max size, which will result in a value which is nothing but the minimum value to make the array balanced. So you can go ahead and return this answer. So the now problem is, how do we find this, right? How do you find this? You can use two pointers, right and left, right? So using which you can for example, you can start with the first position, index position 1, and then you can slowly move to the next subarray with the updated to next position and the last position, and eventually you can when you reach the last position, you can check for the balance condition. If it fails, what you can do is you can again uh, shrink the range, or yeah, it's range, right? So shrink the range, and you continuously repeat that until the last the last range becomes 1. So in this way you can find the subarrays, and you can process things. So before that, you have to, for this condition to work, you have to have nums as sorted. So after sorting this, you can repeat this with two pointers and help finding the subarrays, subarrays with maximum length, in fact. And using that, we can go ahead and subtract with the n, and we can return it. So let me show a try run with the example one, so that you will have a better understanding about how the algorithm works. So we need to track a value. So max val, let that be 0 first, and you have the left pointer as 0, and you will run a loop for a right pointer. So you have 2 1 5, right? So you start at this position, that is nothing but the right and left will be here in this position, right? So you will have this value for which the two in fact I can change the color. Yeah, so this will be 2. So the minimum value is 2 and the maximum value is 2. So this satisfies this condition. 2 lesser than 4, this condition is satisfied, so it is a valid one. So you update the length of this max value to 1, and you move to the next point. The right pointer moves to the next, the left remains here. I can draw it here. So left will be here and right will be here. So again 2 1. So this also satisfies the condition to minimum and maximum 1. So this is the condition and it's satisfied, and hence this is valid. And the length of these two, which is nothing but, how do we calculate, is r minus left plus 1. So this is how you calculate the value. So right, so you calculate the index. Sorry, this is the n value. So now what you will do is you will again move to the next place. So you can check the condition. This will fail. 5 is less than or equal to 4, which is not true. So what you do is, in this position, in this point, you update the left pointer. So you reduce the window size. So the left from here, it updates to this position, so the window becomes this, and you repeat this. Whenever the condition is failed, you shrink the left moves right side, and whenever the condition is true, you move the right, right? So this is how it works, and this is the idea behind the problem. So with all this observation, let us go ahead and code this up. So since we are using the functions to sort this will consume the time complexity of big O of n log n times. N is equal to len of nums, and we have to sort, so nums dot sort, yeah, and you have to have the max val as 0, now left pointer as 0. So for loop for I in range of n, this moves right side, right? So this should be R. So now you will run a while loop until it executes when the condition is right. So while L less than R and nums of L multiplied with K is less than nums of R, right? So this is the condition, this is the opposite of the condition, in fact. So when this, based on this condition, you increment the left pointer by 1, right? So now when you come out of the loop, you have to find the size of the you will have the pointer placed between the ranges, right, within the nums. So now you have to calculate the size. So max val is equal to max of max val, and this should be calculated by R minus L plus 1. Since it is a zeroth index, it means 0 index, we are calculating with adding with 1. So now you repeat the same thing until the right pointer reaches the n minus 1 position, and there is no larger balanced subarray exist until that you process, and when you come out of the loop, you will go ahead and return n minus max val. So let us submit this. Oops, there's a typo. Max val. Yes. And there you go. This is a pretty efficient solution. Thank you.